Hey everybody, and welcome to tutorial 3. So we've talked a lot about getting the computer to be interactive rather than reactive, to interact with information that it receives. But now I guess is the time to start looking at what is that information, what ways can we get real world impulses, gestures into the computer. And so far, we've already been using some powerful ones. The mouse, clicking and dragging on the screen, is a very useful way to interact with the computer. But obviously there's a lot of other routes to explore. So we're going to look at a few of those routes today. The simplest way to get information into the computer in a performance setting, in a real-time setting, is just to use the keyboard and the mouse. But the simplest is the keyboard. There's an object called key that simply reports what key has been pressed. Hook an integer number box up to this, and when I lock my patch and press the letter A, it reports 97. And when I hit the letter B, it reports 98. C will be 99. So that is the ASCII code of the key that's being pressed. And that's not very readable for us. That's not very useful. So there is an object called itoa that takes the integer ASCII code and converts it to the character. If we hook that up to the right inlet of a message box, now I can see A, B, C. And it is useful to have this ASCII code, but it's of course easier to deal with the letters visibly like this. And we can use the select object here, select A space B space C, and now things can happen when I hit the A, B, and C keys on my keyboard. I can connect buttons to these, I can connect toggles to these, I can connect messages to these, and these will go to whatever sound or image or processes that you want to. And when I lock my patch and hit the A key, it bangs this button. When I hit the B key, it turns on and off this toggle. And when I hit the C key, it sends this pause message. C sends the pause. So that's a very simple and straightforward way to access the computer keyboard. And there is similarly a keyup object which reports when a key is released. So I depress the A key and this button will fire, and when I release the A key, it'll appear here. So you can have a separate select for the release of buttons. So C now will pause whatever I have it connected to, presumably a playlist, some sort of playlist object. Will pause it when I hit the C key and resume when I release the C key. I'm just going to make sure that that's actually correct. Messages to the playlist object. Yes, resume is resume playback, and pause is pause playback. So as long as I have this here, we can try it out. I'm holding down the C key to pause it, and then when I let go of the C key, the sound starts again until I depress the C key once again. Now notice here I didn't connect the keyup to the B because the B functions nicely as an on-off toggle, and if I was going to connect the keyup B to the toggle as well, I would connect them to the same toggle. So B turns on the toggle when I press it, turns off the toggle when I release it. However, you still wouldn't want to do it this way. You'd want to be explicit. You'd want to say, turn on the toggle when I press the key, and turn off the toggle when I release the key. Why is that? This is my B key, on, off. Because in the previous version, let me just take these back out for a second. If this toggle gets turned on, now my B down turns it off, and my B up turns on. It's backwards. Now you might want that behavior, but it's an unusual behavior. It's an unexpected behavior. So just putting a message box in here ensures that key down turns it on, and key up turns it off. There's also another method of accessing the keyboard that's quite quick and easy, and not as explicit and flexible as the key and key up objects, but it is quite useful and easy to quickly add keyboard commands into a patch. So I'm just going to go over here to my project, add some media to it, take a few of these and put them into the patch. I'll put a button on each one. I used Command D to duplicate, which, as I mentioned, will maintain the relationship, the spatial relationship between the objects. Then a jit.gl.layer connected to all of these, again holding down Shift to make multiple connections. Jit.world at floating. And look, I typed FL. It prompted me with floating. I just click on floating. I don't have to type the rest of the word. Space 1. There's my floating window. A toggle to turn on my world. And I can send these images to the layer. And if I want these to be controlled by keys, I can certainly use this select and make those connections. Also, I can just enter the assign key map mode and enable these buttons for mapping. Then in this window here, with the three little sliders on it, I can edit those keyboard mappings. So to create a keyboard mapping, I select one of my buttons and just hit the key I want to trigger it, like 1. And notice a mapping is created here. Source 1, parameter button, and there's one additional setting that we want to look to here. This trigger mode defaults to toggle. It's not toggle if it's a button, because it's not a toggle, it's a momentary switch. Here I can click on this one and assign it to 2 simply by selecting it and hitting 2. And now it's assigned, and it's a momentary switch. 3, momentary switch. 4, momentary switch. And 5, momentary switch. Once I have my mappings set up, I can exit my assign key map mode, and now when I hit the 1, it triggers that first image, 2, 3, 4, 5. And note that my key object is also still responding to these numbers. So if I wanted 2 things to happen simultaneously in response to hitting the 1 key, I could connect something else to this button, or I could use the select. Now the one thing to note is, if you're using the key object for number keys, when I hit 1, I don't get the integer 1, I get the symbol 1. So if you want to select for that, you do need to put it in quotation marks because it's not an integer. It's in fact a symbol. It's the text of the number 1 as opposed to the mathematical value of 1. So that's firing this button and also triggering this image because of the mapping. So that's our keyboard section. I'll drop this into a subpatch. And let's look at the mouse. So there is an object called mousestate, and it has toggle outlet for the mouse button, and it has the mouse horizontal location on the screen, the mouse vertical location on the screen, the horizontal delta, and the vertical delta. And we send it the poll message, P-O-L-L, and as soon as we send it the poll message, it starts reporting where the mouse pointer is on the screen and how far the mouse pointer has moved. So notice as I move it slowly to the left, the X position here is -1. It's moving left by 1 pixel at a time, and when I move it right, it's moving right by 1 or 2 pixels at a time. If I move it fast, this delta value increases. So there it just moved 14 pixels. There it moved like 26 pixels, and this is for the Y delta. And the delta is more useful really than the exact screen coordinates. We don't necessarily care that the mouse is at pixel 247 on the X and pixel 416 on the Y. That's potentially useful, but it's probably more useful for us to recognize that the mouse is moving to the right, the mouse is moving to the left, the mouse is moving up, the mouse is moving down. And there's a very useful object that we can use in connection with these delta values. It's useful in a lot of different circumstances. This is one place. It's called the accum, or accumulator. And what it does is it takes a value like this that's changing in increments and just continually adds those changing increments to a stored value. So if we take a look here, the middle inlet adds whatever comes into the current value, and the left inlet, a bang, outputs the value. So we put an integer number box here. As I move my mouse to the right, the numbers go up. As I move my mouse to the left, the numbers go down. If I move it quickly to the right, they'll go up quickly. If I hit the edge of the screen, they'll stop. And that's a limitation of the mousestate object. And we could take this value and reset it at any point simply by sending a 0 into the left inlet of the accum, and that zeroes the accumulator to this point on the screen, the 0. So this would be a great moment to use our key assign. You can't assign a key to a message, so we'll create a button, put it to our 0 message, go into our key mapping mode, enable this button for mapping, select it, and I'll just use the 0 key to assign 0 to that. Leave the mapping, and now when I hit the 0 key, wherever I am on the screen, I can make that my 0 point. Aha! And the one thing I didn't do, which is frustrating, is I did not change this button to momentary switch. By changing it to momentary switch, it's going to function properly like a button. Lock my patch. I'm moving my mouse around, and I want this to be my 0 point, so I hit the 0 key. It clears my accumulator. It sets my accumulator to 0, and now these values coming in will move positive and negative. So if I wanted this to, for instance, be controlling volume, I could set my 0 point over here on the left, and there's an object called scale that simply scales an input range to an output range. So here I'm at 0 to 850 is my range from left to right. So I can say scale 0 to 850 input becomes -70, which is silence, to 0 output. I'd send this into my live.gain, and you'll see that now my volume is low at the left and high over here on the right. And if I don't want it to go outside of this range, I can use an integer number box, and we've seen this before. I can, on the inspector, say I want the minimum value of this number box to be -70, the maximum value of this number box to be 0, and now the values passing through that number box will not go outside of that range. I'm going to re-zero my mouse, and I've got volume continually tracking the position of the x coordinate of the mouse. Now, of course, if I want to be able to turn that on and off, ggate gives us a simple way to do that. And I noticed this in a couple of people's patches. The right outlet of ggate is probably the one you want to use to represent the on state, and the left outlet would represent the off state, because the toggle or message boxes connected to it, it's going to make more sense. A checked toggle suggests something is on, an unchecked toggle suggests something is off. Similarly, a 1 suggests something is on, and 0 suggests something is off. So it doesn't matter which is on and which is off if you're just clicking on this, but if you're controlling it with some external message, it makes a lot of sense to have the right side be your on side. So this limitation of mouse state, that it stops at the edge of the screen, that's problematic because you might want to be able to continuously move a value around. And that's what we get with the HI object. The other benefit that we have with the HI object is it's any human interface object connected to your computer. So it could be a joystick, it could be a trackball, it could be a mouse, it could be a 3D mouse. Anything you hook up via USB to your computer is going to show up on the HI object. So let's take a quick look at that. HI also takes the poll message, but in this case you give it also a number of milliseconds between poll events. So I'm saying poll this HI every 10 milliseconds. And then we do need to choose from our list of devices that are attached to the computer. So we send the HI the menu message, and it generates a list of values that will populate a menu. Our menu object is called umenu. Make one of those. This is a umenu that we make with the N key, the new object key, and connect that to the right outlet of HI, and then connect the middle outlet, the text outlet of the umenu, back up into the HI. And when we click menu, it populates this with all of the USB devices that are connected to my computer, and Bluetooth devices. So for instance, I'm on this Bluetooth mouse right now. So if I select that one, this HI object is looking at my Bluetooth mouse. And if I hook up a message box here, I can see that when I start pulling it, it gives me a 2-element list, 2-integer list. So let's take a look at what that list is. Let's print it and take a look at what's coming out of this object. Switch to my Max window here, and I can see what's coming out of this object. So it looks like my mouse movement is being reported as lists beginning with 28 and 29. If I move my X a lot, I'm seeing activity on 28. If I move my Y a lot, I'm seeing activity on 29. And these numbers are arbitrary. They're going to change from device to device. They don't mean anything in themselves except that these are the numbers that are assigned to the X and Y axes of this mouse. So I can use my route object to route 28 and 29. Take the output of my HI, and I can see my deltas. I can hook up my accum structure to these. And notice that my key mapping does not copy over when I duplicate the object. So my key mapping is still only on this 0. If I wanted these to also 0 when I hit the 0 key, I would need to explicitly assign them also to 0. Go over here. And so you see now I have 3 buttons that are all triggered by 0. The last 2 will be in toggle mode, so I'm going to set them to momentary switch mode. And now, if I exit my mapping mode, the 0 key will 0 all 3 of my accumulators. And here's the difference between mouse state and HI. When I hit the edge of the screen, my mouse state stops, but my HI keeps going. Make this number box larger so we can see. And I can keep going forever. Even though my mouse is bumping against the edge of the screen visually, I can just keep pushing it and the value will keep changing. So that's a big advantage of HI. The other advantage of HI is if you have a 3-button, 5-button, 10-button mouse, if you have a 3D mouse, something like that, HI is going to be able to access all of its parameters. So if we take a look one more time at the max menu, we see that my left mouse button is 13, my middle mouse button is 15, and my right mouse button is 14. So I can simply add those to my route. 13, 15, 14. And there's my left mouse button, my middle mouse button, and my right mouse button is unfortunately going to also call up a contextual menu when I hit it, which kind of gets in the way of it triggering properly, so I can't really use my right mouse button here as an interface object, but I can certainly use my left and middle. I have a scroll wheel on this mouse, and that's coming in at 26 and 27. So I'm going to throw out 14 because it's kind of useless, and I'm going to add 26 and 27 as my scroll wheel. And you're of course going to want to label these. And your device is going to be different. I mean, your numbers in this tutorial will not be 28, 29, 13, 15, 26, 27, unless you happen to have the same Bluetooth mouse that I have. You want to discover your own values. So let's take a look at what 26 and 27 are doing when I scroll the mouse wheel. And this is an unfortunate thing about route. This 27 is all the way over here, but this outlet is the one that corresponds with 27. This outlet corresponds with 26. This outlet corresponds with 15. And you can always see that by holding the mouse over the outlet. And if you want the outlets to correspond more closely with their position on the object, you just need to shrink the object. And now my 27 outlet is under the number 27. It's a messier screen, but it still works. Maybe it's better this way. And this is the nice thing about Macs. There's always more than one way to do it, and you can design your patch for the best readability for you. So let's look at this scroll wheel. 27 doesn't seem to do anything, but when I push the scroll wheel up, I get a 1 for 26, and when I pull the scroll wheel down, I get a -1. So I'm just going to get rid of 27. Don't need it. I'll use my accumulator structure again for the scroll wheel. And now when I scroll my mouse wheel up, I get an increasing number here. When I scroll my mouse wheel down, I get a decreasing number here. So this, you could be changing sound files, you could be changing speed, you could be changing volume, you could be triggering other complex processes. This is just information that you can feed into your patch. If you did want it to control speed of a sound, for instance, a simple structure for that would be scale, say -10 to 10. So when my scroll wheel is anywhere between -10 and 10, my speed will be -1 or backwards to 1 or forwards. So this is going to give me a continuously changing floating point speed. But I need to make these floating point arguments. And that will make the number floating point. So when I scroll my scroll wheel to -10, my speed is set to -1. When I scroll my scroll wheel to 10, my speed would be set to 1. And because I haven't limited this number box, I can push past this and go up to double speed or down to fast backward speeds. But probably what you're going to want to do is add that limitation. So click on that number box, go to the info, and just say I want a minimum speed of backwards normal rate, and I want a maximum speeds of forwards normal rate, or whatever you want to set. And you should probably do this for your own practice. I'm not going to do this to keep the tutorial short, but you should connect this to the speed attribute of a sound player and check and see that it works. So that's interacting with the mouse. So there's two more that I want to look at. I want to look at getting some information from sound input and getting some information from video input. So I'm going to take all of this and encapsulate it as mouse. And let's take a look at sound input. So our sound input device is a graphical object with a microphone, the ezadc. You've got ezdac, easy digital to analog converter. That's how we get sound out. The digital sound in the computer comes out as analog. And ADC, analog to digital converter. The analog sound coming from the microphone is converted into the digital sound of the computer. And I can use the meter tilde object to just have a little VU meter here to make sure that I'm getting sound. And there we are, I'm getting sound. This is meter tilde object. And this is the ezadc tilde, which you can access just from the plus menu. Once you're dealing with sound input, you want to know where your sound is coming from. So under options, you can go to audio status, and this is also where you set your sound output. Like this is my built-in microphone. I actually want to use the USB microphone. And when you switch audio devices, it turns your sound off. You can turn it back on with this button. And now I'm getting my USB microphone, the same one that I'm using to record this tutorial, is also feeding into Max. So there's lots of different kinds of analysis that we can do on this sound. We can look at its pitch, we can look at its timbral qualities, but for today we're just going to look at its volume, we're just going to look at its amplitude and get the loudness of the sound that's coming in to do something. And often that's all you really need. You don't need to do a more detailed analysis of the sound than to look at its shape, its amplitude shape over time, what we call its envelope. It's a very, very useful tool for getting the computer to understand an audio event just happened. Someone just started speaking, or someone made a loud sound or an instrument played a note. So how do we do that? We have to look at its average volume. The object we want is AVG tilde, and that's going to calculate the average amplitude of the sound that's coming into the computer over a certain period. Just like we pulled the mouse, we're kind of pulling the sound, but rather than sampling its current amplitude, we're taking the average of its changing amplitude over time, which is the way to follow the envelope of a sound. I can get into more technical detail on this if you're a sound person, but rest assured that the way to track the changing amplitude of a sound is by averaging it over time. And so we're going to need to send it a periodic pulse. One object that does that is the metro object, which is just a metronome that bangs every so many milliseconds. Let's do it every 100 milliseconds or 10 times a second. We will calculate this average amplitude. We use a floating point number box to see it, turn it on, and now 10 times per second the amplitude is being calculated. And these numbers are quite small. My words are bringing us up to 0.03 here. My loudest is like 0.04. So we can do some math here and just multiply this by 1,000. And we'll see some more readable values. So there, my loudest words are hitting around 50. By scaling them by 1,000, it just moves them into a usable range. Maybe 1,000 is unnecessary. Just putting 100 is sufficient. Right, so now, yeah, my loudest sounds are hitting around 5. And every time I speak, it goes above 1, which of course allows us to say greater than 1. And I'm going to put the decimal point in there so it knows to consider the decimals greater than 1. And now there's something that responds to my voice. Every time I initiate a sound that passes this threshold and the average volume goes above 1, I'm turning on the toggle. So there's something important that you want to add here, which is the change object. The change object only passes a number through when that number changes. So let's take a look at that in the abstract for a second. Change, and I'll put a message box here with a 10 in it, and I'll put an integer number box here, and I'm going to print this. Go to my Max window, clear it out. And when I send 10, it prints 10. When I send 10 again, it doesn't print it again because change only passes a number when it changes. So if I go here and scroll in my number box, it prints all of these numbers because 4 was not 10. So it prints 4, 5, 6, 7, 8, 9, 10. And there it did print a 10 because 9 came before it. So it's only about the one number preceding. So if I hit 10 again, it will print 10 again, and then it won't print 10. If I put a button here on my 16, it prints the 16, but it won't print the 16 again. It won't allow a repeating number to pass through. And the reason why we want this here is because 10 times a second, this average is being calculated, multiplied by 100, and compared to 1. So there's a value coming out of here, and we can print that. There's a value coming out of here 10 times per second. And we don't need all of those. We only need it when it changes. So now, every time my voice rises above the threshold, we get a 1, and every time it drops, we get a 0. So my sustained sound will keep this toggle open. La. And of course, this is very useful. We can now trigger things along with my voice. The other thing that's quite nice is we can trigger things when my voice ends. So simply by doing a select 0 here, right? When this condition goes from being true to being false, I can play a sound. Let's just try that out. So what happens here is as soon as my sound drops,
nothing is more interesting than something.
A sound file will play.
I'm just trying to embrace the nothing.
And this requires a certain amount of vocal control.
I feel tricked and betrayed.
Because the sound is starting the instant my volume drops.
Nothing.
And you see that time it messed up.
I feel tricked and betrayed.
How can we have it wait a little while and hear a little bit of silence to know that it's time to start the sound? There's an object called clocker that will report elapsed time. So when I hit the button, it starts counting milliseconds. We can look at this in seconds, as we've seen before. Just divide by 1,000, so it's kind of not crazy to look at. There, so I hit the button, and it starts counting from 0, 3 seconds, 4 seconds, 5 seconds. So we can have this 0 start our clocker counting in order to make it wait a certain amount of time. Let's say a half a second. Before starting the sound. A half a second might even be more than we need. And again, look, it's going crazy here. That's because we again need a change object here. So this isn't sufficient though. If I start making sound again before a half second, we don't want the clocker to start counting again. We want the clocker to just stop. So here, when I start making sound, we're going to stop the clocker. And put that number box back in there so we can see what's happening. So the button resets the clocker, and the stop button stops it. So every time my sound drops below the threshold, the clock starts. Every time my sound rises above the threshold, the clock stops. And if the sound drops below the threshold for more than a half a second, it will trigger a sound. Let's see if that works. We'll see if my sound, if I can speak in a natural way without causing the drop.
I'm just trying to embrace the nothing.
And we'll see if, yeah, I can do this without needing to have an artificial vocal performance.
I'm not becoming a Buddhist, but I'm trying to be more Buddha-like.
So yeah, we can tweak this to get it to work better, but fundamentally, she's speaking whenever I'm not.
I feel tricked and betrayed.
And nothing happened when her sound file ends. I have to speak again and then stop again.
By us talking about nothing, nothing becomes more like something.
So the final section we want to look at is video, and video is somewhat more complicated. Fortunately, there's an entire library, an entire extension dedicated to this that we can add into Max to make that work easier. So again, I'll just encapsulate this work here. And I'm going to add a package from the package manager. The package manager is this little cube right here. And the package we're going to add is called cv.jit. So type in cv here in the search box, click on cv.jit, and install cv.jit. What this is a library of computer vision algorithms implemented in Macs that will make dealing with image processing much, much easier. So we know how to get the image into the computer. jit.grab with a toggle to turn it on. And we know to turn on our entire image system, we need a jit.world. And I'll give it a floating window at floating space 1. And for the moment, it's not important to send this image to a jit.gl.layer. We want to send it to a preview window in our patcher. So we'll send it to a jit.pwindow. That's a new object that just creates a little preview window in the patcher. This is jit.pwindow. Turn on my video, turn on my world, and there I am. Hello. And so this is just a little resizable preview window. There's a couple things we want to do to prepare for triggering things from live video. The first thing is it's really hard to work in a mirror image. You just want to flip your image horizontally. So jit.dimmap at invert 1, 0. What this object does is it does a number of things, but in this case the at invert attribute causes it to flip the image horizontally. So we're going to flip it horizontally and not vertically. Just insert this and notice the image will flip around. So now when I raise my right hand, I see my right hand on the right side of the screen, and this is just a lot easier if you're controlling something with a visual reference on the screen to see where you are. You want the flipped image. The other thing we're going to do, if we take a look, there's an object called jit.fpsgui. That's a jit.pwindow, and this is a jit.fpsgui. Frames per second graphical user interface is what it stands for. And this shows us more than just frames per second. It also shows us the dimensions of our image. And we see we've got a high resolution image, 1552 pixels square. And since we're running computer vision algorithms, we want to work with a lower resolution. So a way to drop the resolution of an image is to use the jit.matrix, which is an object we're going to talk about a lot later, with the following arguments. 4, meaning 4 planes of information, in this case, transparency, red, green, and blue, or ARGB, alpha, red, green, blue. Char, meaning values between 0 and 255, which is a standard way of representing color that if you've done web design, for instance, you're familiar with. When the image comes in raw from the camera, it is in 4-char format, 4-plane character type data. And we'll just knock it down to 200 by 200 pixels. So now, if we put our FPSGUI here, we see that our image resolution has dropped from 1552 by 1552 down to 200 by 200, and we can also size our P window to match our pixel dimensions. And in fact, you have to do this for something we're going to do later. The window dimensions must match the dimensions of the video itself. So this is not just for cosmetic purposes. So compact this. And then there's one other step to prep this image for putting it into the computer vision algorithms, and that is to take it down to black and white. There's an object for that, jit.rgb to luma, red, green, blue, meaning full color, to luma, meaning just the luminosity information, or just the brightness information, or black and white. So now we have a black and white image, and now if you've installed the cv.jit package you should be able to type in an object called cv.jit.track. And cv.jit.track is going to analyze features of an image and track objects within the image. So the next step here is we're going to just get our full color image into this window, and we're going to pick a point to track. And the way we're going to do that is by using this jit.pwindow, because if I stick a message box on the right outlet and lock my patch, it reports the mouse location when I click. So this allows me to specify what pixel I'm interested in. And we can see this is in a list format, mouse, and then the X and the Y coordinates, and then a bunch of other numbers related to whether the mouse button is down, whether I'm holding down Shift, whether I'm holding down Command, etc. We just care about the X and Y position. So we're going to route mouse, and we're familiar with route. It looks for the first word in a list, chops it off, and sends out the rest of the list. So now I'm getting just the pixel information and then all these other numbers that I don't need. And then I'm going to use the pack object to pack the list set, the word set, and then 3 integers. And if I just connect a button to the left inlet of pack, this set won't become bang. This set will be sent out as set. And then I'm going to take my 2 integers from the route mouse, and I'm also going to use an integer number box to select which point I want to track. And let's see what that does. So my 0th point will be 5795 pixel coordinates. And then if I want to track another point, my next point will be at 171, 110. And this way I can define as many tracking points within the image as I want. And then also cv.jit.track has an attribute called endpoints, which is how many points it's tracking. By default, it's only tracking 1 point, so we're going to start with that. Tracking 1 point, and the first point is point 0. In this message, set 0, and then the pixel coordinates gets sent right up to the cv.jit.track. This is a format that it understands. So in order to visualize this, I've created an abstraction called j.cv.track.draw. You can download this from the Discord server. It also will appear in the comments section of the YouTube video. And you can see that this is just a patcher that does a little bit of processing on the output of the cv.jit.track and draws it as a colored dot on the screen just to make it a bit more visible. And then also we're going to want to do a jit.gl.layer so that we can see our image. And then I can put my hand up into the image, lock my patch, click to define a point, and now that point is being tracked. By the algorithm. And if I want to define a second point, I can turn this up to 2 points and define point number 1. I'll put it on my eye here, and now I have 2 defined points within the image that are being tracked. And so if I want to define a third point, I take my endpoints up to 3, and I can change this to point number 2. I can define, for instance, my beard, and now tracking 3 points. And you can track an unlimited number of points. And does it get confused? Absolutely. And it tries to get back if it gets confused, and occasionally it gets too confused, like this. My green point just stuck to the wall. That was point number 1. so I can just put it back on my eye. But these points are being tracked in real time, and another feature of the j.cv.track.draw is that it is giving you the information about these points in a format that you're comfortable working with, which is a 3-element list, point number followed by the x coordinate followed by the y coordinate. So if I route 0, 1, and 2, that's going to give me the coordinates of my 3 points. There's coordinates of point 0, coordinates of point 1 into the right inlet, and coordinates of point 2. And since you're dealing with a 2-element list here that you are going to want to break apart into the separate numbers, you would use the unpack object. You're familiar with the pack object, both flavors of the pack object. The unpack object is the opposite. It just takes the list. In this case, we want to specify this list is made of 2 floating point values. Use a floating point number box that I create with the F key. And this allows us to get to these 2 numbers for each of the points. And this information is, I lost my point number 0. Let's go back and find that point number 0 again. So now it's tracking that point number 0. It's giving me from 0 on the left edge of the screen over to 1, close to 1 on the right edge of the screen. It's giving me close to 0 at the top of the screen. And, oops, it gets stuck on that bar. It can't get past that bar. Got to take it. No. It's stuck. All right, so I got to just relearn it. Take it over here to take it to the bottom of the screen, and we see it's close to 1 on the y-axis down here. And so you can use the green dot on my face. Just move it to my ear. You can take this information and apply it to anything. Volume, pitch. You can use the greater than and less than to set thresholds. So for instance, when the dot is on the right of the screen, do something. And these values are what we call normalized values. They're between 0 and 1, so it's very easy to scale them with scale 0 to 1 corresponds to whatever value range you want. If you're going to use it as volume, you'd scale 0 to 1 to minus 70 to 0, and that's going to work with your live.gain, or you could, if you wanted to step through a number of sound or image files, you could scale from 0 to 1 to 1 through 10 and hook that up to an integer, and then you're going to, on the y-axis, just be moving from 1 to 10. Get stuck on my mic. So down here it doesn't quite get to 10. 9, 8, 7, 6. Yeah. Can't. Yeah, there's sound 1 or image 1, 2, 3, 4, 5, etc. down the screen.